Welcome back, guys. In this video, we're going to look at how to solve a rather challenging density problem. So in this problem, we're told that we have a ball, we're given the mass of the ball, 11 pounds, and we're given the circumference of this ball. And we need to do two things. We need to first calculate the density of this ball, and then we want to figure out whether or not this ball will float in water. Okay? So this represents, as I said, probably one of the more challenging density problems you're likely to see in the course. And really the challenge comes down to having to pull together a lot of the concepts we've talked about thus far. Right? So the first thing I want to do in tackling one of these more complex problems is break this down into two steps. The first step, I want us to take a look at the density. Okay? We want to calculate this density. So the density of any object, right, you guys have to remember, is related to the mass and volume. Specifically, density equals mass over volume. Okay? So that's the first thing I want you guys to think about. When you're reading a problem, I want you to pull out what it is that we're looking for, in this case density, and I want you to think about what sort of relationships do you know. Mass over volume in this case. Okay? Having written this down, then our task comes down to looking at what other information is given to us to figure out how we can go about solving for the density. In other words, does the problem tell us what the mass and volume of this object is? Well, the answer is not directly. The mass is 11 pounds. Okay? So we have a mass. However, the volume is not directly provided for. All we're given is this fact that we have a circumference of 27 inches. Right? So what we're going to have to do then is somehow translate this 27-inch circumference into a volume. Now this is going to be a multi-step process. The problem tells us a couple hints that will help us along the way. So the first hint that's provided is this guy right here. This relationship C equals 2 pi r. All right? This relationship is telling us that C, the circumference of the ball, is equal to 2 times pi times the radius of that ball. All right? So we want to think, well, how might this be helpful? Well, if we plug in our 27 for the circumference, we would then be able to solve for the radius. Right? And once we have the radius of a ball, we know we can determine the volume. For a sphere, for a ball, the volume is equal to 4/3 pi r cubed. So at this point, right, we can use this circumference value, plug it in here, find r, plug in r here, and get a volume, and then plug that into our density formula. So that's sort of the roadmap that we need to follow. Okay? So we've already at this point had to use a total of 1, 2, 3 equations in order to really build our roadmap. Now there's another challenge with this problem. At the end of the day, we not only want the density, but we want the density relative to water. Why? Well, we need to determine whether or not this ball is going to float. To determine whether or not an object is going to float, we need to be able to compare the relative densities of the two different materials. So in this case, we're comparing to water, which has a density of approximately 1 gram per centimeter squared. Centimeter cubed, rather. So I'm going to write that down. So the density, we typically use a symbol rho here, of water is roughly 1 gram per centimeter cubed. Okay? So 1 gram per centimeter cubed, which means if I need to determine the density of the ball in grams per centimeter cubed. So before we plug into all of our equations here, what we're going to have to do is carry out some unit conversions, a set of unit conversion problems. So the first one we're going to do is go ahead and take that mass, right? The given mass here is 11 pounds. Okay? Okay? So we're going to take our mass and we're going to do a little mass calculation. And so the mass calculation here is going to involve our equation right here that allows us to change mass from units of pounds to units of grams. So let's see how we do that. Well, if we've got 11 pounds, all right, we need to multiply by something that gets rid of pounds, cancels out the pounds, which means we're going to want pounds in the denominator, and we want to end up with grams in the numerator, right? So pounds will cancel, right? Now, what is the relationship between grams and pounds? Well, we follow directly from our equation here. We see that there is 1 pound is 453.6 grams. And if we carry that out, which I did here, we have 4989.6. Okay? So that's the total mass in grams of our ball. Now notice I'm keeping all of the digits that came out of the calculator. We're going to do that throughout all these unit conversions, throughout the problem, and then round at the very end according to how many sig figs we should have based on the given values. So we're going to keep that total mass for right now. Now, this gives us our mass term. All right. Our next task now is to determine what this volume is going to be. And again, this is the one we're going to have to use all of these equations we just talked about. So our first step here, though, will be to make sure that we are in units that are convenient for the comparison with water. So we're going to have to convert everything from inches into units of centimeters. So let's carry that one out. Well, we're told that we have 27 inches. All right. 27 inches, we have another conversion factor right here that will allow us, I'm going to move this down a little bit, 27 inches. A conversion factor right here that tells us that for every 1 inch, there are 2.54 centimeters. Inches will then cancel out, and if we plug this in the calculator, you should get a value of about 68.58 centimeters. Again, not rounding this, waiting till the very end to do so. Okay, so now we have the circumference given to us in centimeters, right? So I'm going to write that down here to really sort of guide our thoughts. So C given to us in centimeters. Now what we're going to have to do is use our circumference equation here to solve for radius. So the radius is going to be equal to C over 2 pi. Okay? C, we just determined above here, is 68.58 centimeters. Okay? So again, just bringing this term down. And I'm going to divide that by 2 pi to get a value for the radius. Again, plugging it into the calculator, not rounding, we get a value of 10.91 centimeters. Right? So this is our radius now. Now, finally, once we have the radius calculated, we can use our last equation down here, which tells us the volume, right? And we can determine that the volume, which is equal to 4/3 pi r cubed. We're going to plug in the value of the radius that we just determined. Pi times 10.91 centimeters cubed. All right? If we plug all that in, you should get a value of 5439 centimeters cubed. Because remember, we are cubing both this number and the unit associated with that number. So we're ending up with units of centimeters cubed. Now, we have values, which I will reproduce over here for ease of reference. We have values for the mass, right? The mass is 498.9.6 grams. And we have a value for the volume, right? Volume is 5439 centimeters cubed, all right? So our last step now that we have a mass and a volume, is to plug into our original expression for the density to determine the density of our ball. Okay, and because we're doing the density of the ball and we're in units of grams and centimeters cubed, as you can see, we're going to be able to, as planned, directly compare with our density of water. So the density of the ball now, okay, is going to be the mass of the ball, right, which I actually gave you in pink here, right? It's going to be the mass of the ball, make that orange, okay, divided by the volume of the ball. We'll put a big V on that one. Volume of the ball, okay? So plugging in the values that were given here, right? Mass is going to be our 4989.6 grams. Okay, and the volume here is going to be 5439 centimeters cubed. So if you divide these numbers through, you should end up with a value of 0.92, and our units are going to be grams per centimeters cubed, as we wanted. Now, this is the density, all right? This is the density of our ball. Now, our final step is to determine whether or not it's going to float in water. So we can obviously see here that 0.92 is less than 1, all right? Therefore, the density of the ball is less than the density of water, H2O, so we can conclude that the ball will, in fact, float.